I'm Rick Esselink, and I've been working as a hobby with Bitcoin Wednesday in Amsterdam for quite some years now, and it's great, Chris, to have you pass through Amsterdam and to learn about the work you're doing. I think before we get into the details on the Lightning Network and Blockstream, it would be really great to hear a little bit about yourself. We know that you are originally German, living in Switzerland now, and that you got into Bitcoin and blockchain before most of us even knew it existed back in 2009. Could you tell us about yourself in those early years?
Yeah, thank you very much for having me. So yeah, I learned about Bitcoin in early 2009 by reading some obscure blog, and I thought, okay, this is interesting. Since I was doing a master's in distributed computing anyway, I was sort of intrigued what this is and why it could work and why this could probably never work. It's I mean, so many people have tried before, and so I read into the paper, and it took me quite a while. And once I got the full image, I thought to myself, okay, yeah, this is sort of a nice hobby. I could do some work on it. And then later, we started having some in-person meetings. In 2011, we had the first Bitcoin meetup in Zurich, at the time with Mike Hearn and Stefan Thomas from Ripple, and one other person whose name escapes me now. But it was us four, and we still have one of these pictures. And once you start meeting in person, you have this whole different dynamic that you're actually trying to dig deeper and improve on the existing system. Yeah. And in 2012, when I finished my master's, it was time to choose whether to go into industry or to continue working on a PhD. And I chose to do a PhD, and the topic wasn't that far away. Right. I was a bit hesitant to propose Bitcoin because, well, it could still crash and burn and not be around long enough for me to finish my PhD.
Yeah, and it was probably even considerably lower in acceptance than it is now. Even now, a lot of people think we're weird being involved with Bitcoin. Back in 2011, most people thought you were crazy, right?
I remember the first time I told my parents that I had this new hobby called Bitcoin, and it's a cryptocurrency. I had to immediately follow up by saying that no, I didn't invest anything in this craze. I'm just mining, and then I had to explain to them what mining is. But all my fears were in vain. They were actually pretty supportive when it comes to Bitcoin. So
in the 2009 to 11 years, you were doing this alongside your studies, and you were doing some mining.
So back then it was still possible to mine on a virtual CPU on a VMware virtual machine. And I actually forgot about the Bitcoin client running on one of these VMware machines for a few months before I then read again in some blog post that, hey, this is now worth some money. And I went and looked, and and indeed I had some Bitcoins. Right. And there goes the interest again. It's resparked, and I never lost touch with Bitcoin.
It's actually a nice story then, because you told your parents you wouldn't invest, but you actually mined. So
I mean, I had these resources lying around, wasn't doing anything, and I was active on the forum. So we cobbled up a headless version of Bitcoin, which later became Bitcoin D. So with that, we could actually run this in the background without having to have a window open or you're running your machine in the same room.
Right. Okay. Well, tell us about your PhD.
So yeah, when I first read the Bitcoin paper, it sounded kind of amazing that this could actually work. I mean, this is a system where everybody gets to see everything. If I buy a coffee, this transaction goes around the world and is verified by thousands of computers. And obviously, if every single node needs to verify every single transaction, then you have the problem that the smallest node, or the node with the least capacity, is the bottleneck of the entire system. Yeah. So either you scale up the requirements for the nodes, which you can do up to a certain limit, yeah, or you come up with something completely different. Yeah. So the scalability issue was pretty much at the core of my research proposal, and it's also at the core of the entire dissertation. Right. We came up with a number of protocols that we can use with different trade-offs. Some are what we nowadays would classify as on-chain protocols. Some of them are off-chain protocols. Yeah. And it was a really interesting time, because you had, yeah, this huge research area where you could just start building stuff and, yeah, know that you'd be the first to build stuff there.
Yeah, that's exciting. And I guess this PhD is also one of the reasons why you ended up at Blockstream where you are now, right? Can you tell us about that?
Well, the main reason is because I knew many of the people, right? Okay. Yeah. I'm not sure they were actually that interested in my PhD, right. But I knew quite a few people, both from the forum as well from the mailing list, and right. Peter Vullier, one of the co-founders, is actually from Zurich. Okay. So we know each other pretty well, and when time came, they approached me and said, hey, how about it? Would you like to join? And I got the opportunity to basically continue working on the same topics that I addressed during my PhD.
Right, you got to work on some of the solutions to the problems you raised.
Exactly, yeah. So one of my last research results was duplex micropayment channels, yeah. An off-chain system which was pretty similar to Lightning. Yeah. They scooped us. Okay. But yeah, we went through the academic review stuff, and that always takes time. So it was under review while Lightning published theirs. Right. And now we sort of we decided to band together and work out Lightning as one huge contiguous system right. for payments.
Okay, so then I think what we're keen to hear more about is about Lightning. But I think before going into Lightning, could you explain in a little bit more detail the real core need? We understand that Bitcoin has a scalability issue, both in the handling the number of transactions, yeah. as well as the speed and the cost in dealing with those transactions. These are many of the problems that you already looked at your PhD in the early days. So what are the real blockers that make Bitcoin not scalable?
Blockers is a good word there. I think the first and last issue are coupled together. The limit of the scalability is basically the limit of transactions we can process in a certain amount of time. If we raise the cost, we can also increase the number of transactions we can confirm. However, this goes against the basic principle that Bitcoin had, that basically anybody can join, and the idea of having one CPU, one vote. Right. Being able to independently verify that everything is okay and nobody got cheated along the way. Right. A second issue you mentioned was the latency for payments, yeah. Which is basically that if you perform a payment, then you have to wait for it to be confirmed in a block, which in the absence of contention for block space is 10 minutes in expectation, which is not optimal if you want to buy a coffee, for example. Right. I mean, right. I'd approach the counter, I'd ask for my coffee, and basically what you end up is having is getting a cold coffee once the transaction is confirmed. Right. So yeah, I guess there are these two big big dimensions of the scalability issue. One is the throughput, and the other one is the latency. And we can address both of them with higher level protocols that still build on top of Bitcoin,
right.
But remove this need for everybody to see every transaction.
Right. So, right, because Lightning is not actually a change to the Bitcoin protocol itself, but it's running alongside. Correct? Can you explain? Can you explain to us what is Lightning then?
Oh, that's a $1 million question. So in Lightning, we basically set up a system between two endpoints of a payment called a channel, which basically boils down to us two having a shared account.
Right.
And let's say that you are the seller of coffee, and I am buyer, a regular. I'll put 10 Bitcoin into this channel. This channel is a shared account which requires both signatures from you and me. And then on the other side, we close the channel by spending these funds again onwards to somebody else. In the first instance, we pay all 10 of them back to me and 0 to you because, well, I haven't bought anything from you.
Right.
As soon as I perform the first payment, I'll basically ask you for my coffee and give you a transaction that from this shared account sends 1 Bitcoin to you and 9 back to me, assuming
right.
that the cost of coffee is 1 Bitcoin, which is pretty expensive nowadays. Yes. I just realized. That better has to be a good coffee. Right. So I sign this transaction, but of course this transaction coming from this shared account needs both mine and your signature. Yeah. Yours is still missing, yeah. But I give the half-signed transaction, I give it to you. Yeah. And you basically now have a choice, right? You can either add your signature and publish it, right, claiming the 1 Bitcoin, right, or you can say, hey, this guy's a regular, maybe he comes back tomorrow. Right. And if I then indeed come back tomorrow, I can create a new transaction from the shared account, okay, that now double spends the old transaction. Right. But now you get 2 Bitcoin and I get 8 Bitcoins. Okay. And again, I sign and give it to you. Yeah. Now you have again the choice. Do I add my own signature and broadcast it, or right, do I wait for me to come back? Okay. So what we just did is we just did an incremental payment from this shared account, right, from me to you. Right. And whenever we feel like, yeah, I move away from Amsterdam, I'm not coming anymore to buy your coffee, right, then you can say, okay, yeah, it's time for me to get to close the channel. You take, right, the latest version of the settlement, right, and you broadcast it to the network. Okay, so I'm going to try to sell you a lot of coffees because it sounds like a good business. But with that price, yes. Basically, these what then triggers it getting posted back to the blockchain of Bitcoin? So this, I should probably mention, this is this is a simple micropayment, right, channel. Right. This is not Lightning just yet. Right. I can't basically misbehave, right? Right. Because you are in power. You choose which one of these transactions to sign, yeah, and when to sign it. Yeah. So either I can come to you and say, hey, let's please close the channel. Right. And then you sign and broadcast. Right. Or I disappear and you suddenly realize, hey, I need to pay my supplier. Right. I need to cash in. Right. So you go sign and broadcast to the network as a whole. Okay. Okay. And so what this will result in is a much faster throughput, because I assume, yes. So the main construction is we have 1 setup transaction and, yeah, we have 1 teardown transactions. These, right, are on-chain transactions right, with all the same upsides and downsides of, right, Bitcoin. But what happens in between the setup and the teardown phase? Right. We can do as many updates as we want. Right. I can give you incremental payments as long, right, as I want. Right. I can do them at a very high rate. Right. Basically at the same latency we can speak, right, will be the same latency of the, right, payments being confirmed. Right. Because once you get my half-signed transaction, you, right, are assured that you will get the funds in the end, right? Right. Right. you always hold in your hand the tools to enforce our agreement, right? So we have moved from a system that has a 10-minute latency to milliseconds.
Milliseconds.
Yeah.
And what is it running on? Is it decentralized? Is it what's the the platform that it's running on? Is it?
Not sure what you mean by platform. This is an agreement between just us two.
Right.
The underlying layer is Bitcoin, of course.
It's Bitcoin. Right. But you're creating a side channel, right? Which isn't using the Bitcoin network.
So yes,
Yeah.
it's a communication channel between us two that we agree on how to handle this.
Right.
We don't need to publish the intermediate states to the blockchain.
Right.
It's just between us two. Yeah.
Okay. But what do I need then to be able to run
Oh,
this?
you need you basically need a wallet that supports micropayments.
Okay. So this can be, but then it's basically peer-to-peer.
It is a peer-to-peer system.
Right.
And yeah, it's basically just that.
Okay.
We agree to set up this channel, and we agree on the details,
right.
And nobody else has to know.
Right. So the that triggers me a bit, because then the original Bitcoin principle was that all the transactions are recorded on the blockchain, so that if there ever is a dispute or a question, then it's possible to go back, and it's there for all history, immutable. In this case, where what happened between us isn't actually recorded, just the final settlement, right? So is this violating the original principles of Bitcoin?
I actually wouldn't say that recording every single transaction is one of the principles of the blockchain. The principle of the blockchain is enabling direct payments between any two endpoints without having interference from third parties.
Right.
So having this ability to go and look up transfers on the blockchain is a nice feature, but it's also a huge downside if you look at privacy. Yeah. Because if I were to buy every single coffee on chain, then somebody could come along and try to find patterns in the transactions, and cluster addresses, and build profiles about who is using Bitcoin, where are they moving money, maybe front runs on stuff. Right. And there are people actually doing this. I myself did a few student projects with students that were looking into characterizing where the big flows are. Right.
Yeah. There's
and I mean this openness can be both good and it can be bad. A few months ago, the WITSEC published a big flow diagram of where the alleged Mt. Gox funds ended up, and it turns out that they ended up at a different exchange and were probably sold off. Yeah. And if you look very closely down below there is also my name, because I had some funds stolen as well. So this openness is both a good and a bad side of the system. By adding Lightning, we don't lose that though. By what we publish to the blockchain is an aggregate of all the transfers that happened between the setup and teardown. Right. And there is a cryptographic chain of transfers that happened between us two. And by publishing part of that, I can actually prove that a certain transfer has happened between us two at a certain point in time. Okay. Now, so far we've only talked about simple micropayment channels. Right. Not Lightning yet, and we haven't touched on the multi-hop payments. Right. And in the multi-hop payments, we actually have a far more advanced feature called the HLCs. Yeah. Which can be used to create an atomic receipt for every transfer. Okay. So what you basically create is, say, you're creating an invoice that I have to pay. Right. And this invoice basically says, okay, I will give you the service or goods if you can show me if you perform a transfer. And this transfer is predicated on me revealing a secret to you. Okay. And by the way, here is the hash of the secret.
Right. Okay.
So the invoice basically has a description, it has an amount, and it has a destination address, and it has a so-called payment hash.
Yeah.
Now I will create an updated version of our channel, which includes one output going either to you or to me, depending on whether a timeout happened or you reveal the secret. So what I basically do is I approach you and say, hey, if you can show me the secret matching this hash,
right,
you can grab the money.
Right.
And so you revealing the secret automatically acts as a confirmation that you've received the money.
Right.
Because if you didn't, nobody would ever have seen that secret.
Okay.
So me having a signed contract by you saying, hey, I will deliver when you pay, and here is the hash of the secret that I will have to reveal for this transfer to be sealed and done.
Right.
And me being able to provide you with the secret basically shows you, hey, this contract was.
So that would be potentially for larger transactions with the delay when something is delivered?
So in the first place, this is a mechanism for us to have multi-hop payments.
Yep.
So if we have a direct channel, this whole system is pretty easy, right? I can just push money to you.
Right.
Right. If we had a third party between us and I had a channel open to him and he would have an open channel to you, then I would basically, without HLCs, I would push money to him, telling him, hey, please forward it onwards. Right. And then he could say, nah, I'll just go away.
Okay.
So what the HLC is doing here is basically promising him some money if he can show me a secret.
Right.
He doesn't know the secret, but I give him a hint that he might ask you for the secret. So he now can go on and ask you for the secret, and you being the intended recipient, obviously, have the secret.
Right.
So you can trigger this whole chain of payments.
Right.
Where giving you pulling the funds gives him the secret.
Right.
Him pulling the funds gives me the secret.
Right.
So we have this end-to-end payment with receipts, with security, and all of this just happened in the same time we needed to communicate.
Okay. Okay. That's so. What are maybe some then examples or additional things that Lightning will enable?
Yeah. So we have. There's a couple of things that Bitcoin is currently not best suited for. Mainly these are for micropayments.
So the real big one everybody wants is a lot of these micropayments. So,
exactly. So yeah, we can do thousands of transfers per second on between any two endpoints.
Yeah, at affordable cost.
At affordable cost. Yes, we actually moved from a fee that was size based in Bitcoin because you pay for storage on the blockchain, to a fee that is value based, because now we are actually we can charge you more for bigger transfers.
Okay.
The whole idea being that you just consume more of the capacity of a channel, so you ought to be paying more.
Right.
But we hope that fees will actually be very minimal.
Right.
So the fees in Lightning are actually denominated in millionths of a Satoshi.
Millions of Satoshi. Okay.
Small bit of accounting tricks, but it actually works out fine. Okay. Yes, we have this proportional fee now to your payment, and no longer I want to transfer $2 and have to pay $2 of fee. Right. We have the immediate clearing of these payments. So once you have received the payment, it's final. We don't need to wait for block confirmations or settlement on chain. Right. And we can, I think I already mentioned the high rate, right?
Right. So how and when can we try it?
You can try it right now. I'll actually be demoing a version later on. Not on mainnet though. I mean, the whole Lightning community is made up of a couple of companies, and we are very interested in collaborating and having and building one huge contiguous network, because that's where the value comes from.
Right.
It's no use if every company builds their own small Lightning network with some subtle differences and we can't interoperate. We actually want to be able to have every implementation working against each other. So we currently are still working on a specification that's slowly slowing down when it comes to changes. The implementations are sort of up to par with the implementation, and I'm currently integration testing between the implementations. And so hopefully we will have a working mainnet network soon.
Okay.
If you want to test it now, you can download any one of the three clients, Eclair, LND, or C Lightning.
Right.
And start it on RegTest or testnet, or well, some people have also done it, used it on Litecoin.
Okay. On Litecoin as well. Okay.
Yeah, well, they deployed Segwit before Bitcoin, so it was a great opportunity for us to test whether we can actually do the jump, or whether there are some hard-coded values, for example, that we haven't seen.
Right.
And it turns out there are. I ran into that myself with the dust limit of Litecoin, which is way higher than Bitcoin.
Right.
And we sort of had this dust limit hard-coded in there.
Okay.
So the implementations are out there, are being
adoption
developed on GitHub, and people are starting to build interfaces on top of them.
And for adoption, is there I don't know if you're the right person to ask, but are there certain kind of early targets to go for adoption here?
Not sure we actually have official targets. It's mostly we'd like to see people starting to test Lightning and see how it fits into their day-to-day work. See whether all the pieces are there for that they need. There are still a few rough edges around stuff, so we definitely do not want to have a huge ramp up right at the beginning where millions of people join. Simply because, well, this is all untested software, so be careful about what you put on these channels. And in order to limit that, we also have an agreed upon maximum number of Bitcoins you can currently put on a single channel, which is quite a lot more than when we started off with the whole design.
You guys are also even talking about machine-to-machine transactions, right?
Yes.
So we can start to get to the really high numbers with that.
So I mean, there's basically no limit to the number of transactions we can do on Lightning. The only limit that we actually have is how many channels can we open with the Bitcoin network as it is today, because we still need on-chain transactions to open a channel. Right.
Okay. So where should people go to learn more? I know your presentation you'll share later on this evening, along with the demo, will also be recorded. However, if people want to go online and get more information, what's the best place?
Good question. I think the lightning.network webpage is a good one to get started with. It hosts the original paper by Taj and Joseph. We do have a mailing list. It's lightningdev@lists.linuxfoundation.org, I guess.
Lightning Death?
Lightning Dev.
Lightning Dev.
Yeah.
Okay.
And we have IRC channels on Freenet.
Okay.
I guess that's #lightning-dev.
Okay.
And there you can reach us with help or suggestions or whatever.
Okay. Well, thanks very much. It's really good to have you. We're looking forward to what you'll share later on this evening as well. And this is certainly, I think, will trigger a lot of interest. It's addressing the problems that you already saw when you started looking at Bitcoin back in 2009. So I think it's a particularly, it's also unusual to have somebody that was really already there since the very beginning. So really enjoy having you join us and enjoy meeting you. Thanks.
Yeah.